to reach its full potential. So as I've said, my job today is really to help you guys make the most of the rest of the week by giving you a grounding in the concepts and ideas and technologies that you'll need to be familiar with to understand or make the most of the rest of the school, from a semantic web perspective particularly. So I want to give you a history of data on the web. So this is making the most of my years as a web developer back in the early 2000s, and from there I moved to do my PhD in 2004. And the reason for that move was primarily because I've encountered the frustration of trying to publish data on the web and trying to add more structure to the content that I was publishing on the web, and I felt that there wasn't the mechanisms within the technology stack, the existing technology stack, to enable me to do that. So rewinding further back, about 25 years practically, then I want to emphasize the fact that we often think of data on the web as a new thing, or as a kind of a recent concept, a recent development, an evolutionary trend. But I think that if we read this quote from Tim Berners-Lee's original proposal from 1989, we can see that data features so heavily in this. It says, if there was an existing base of data, of personnel, for example, to which new data could be linked, the value of each new piece of data would be greater. So you can see in this, way back, almost 25 years ago, Tim was already thinking about the web as a platform for data and a platform for connecting that data together. To give you another example, in news articles, for example, one could use in the text a standard format for a reference to another article. This would be picked out by the hypertext gateway and used to generate a link to that note. And you can see in this that there's all sorts of weird terminology that we just don't think of anymore, like a hypertext gateway. What is a hypertext gateway? I don't know. But we think about browsers and search engines now. But you can see that already in this, he had a concept of adding structured data to the content on the web, which would enable applications to process that in a more effective way. So what happened next? Like, why, with all this data, link, blah, structure, whatever, in that original vision, why are we now talking about this as cutting edge in 2013? The reality is that the document web was such a revolution that we just didn't care about the data at the time. We got distracted. There'd never been a platform before for worldwide sharing of documents that were accessible to anyone with an internet connection. It was just unprecedented. And that was such a revolution that we were so busy for many years building the things that exploited the fact that we could share documents. And then, over time, people started to think, well, actually, I want to use this platform as a way of sharing data. So I want to use the web as a file system. So I have a big dump of data, a CSV file or a database dump or something, and I want to just distribute that in some way. So people put that stuff on the web and then shifted it around. It wasn't in the web, it was just there placed on the web. It wasn't really connected to much else. The data in that wasn't connected to other relevant data sets elsewhere on the web. It was just like a file system, a plain file system. So that was one kind of facet of data on the web in the early years. The other facet, which is very different, was that people were, over time, got more and more aware of the idea of adding a little bit more structure to their HTML documents. So people like, I remember a time in the early 2000s when it was a kind of radical idea to use proper semantic HTML. So this was one of the manifestations of this. There was a campaign for POSH, plain old semantic HTML. What did this mean? It means don't have a paragraph tag and define some styles, some HTML or CSS styles to make it appear big on the page. Use an H1 tag and use the address tag if you've got an address on it. It's really, really simple stuff in HTML, but there was a time when people didn't do this. But over time, people realized that by adding more structure, more semantics to their HTML, then they could actually improve the quality of how this was rendered and how the data or the content was interpreted by things like search engines. So people started doing this when they realized that if you put something in an H1 tag, then search engines will pay attention to the fact that this is some of the most important content on the web. And so people started doing it. There was an incentive for them to add more structure. A continuation of this trend was known as, or is known as, microformats. And this is something that's been going for a number of years and is still an active community. And the idea here was to add very granular fragments of structured markup to your HTML document. It's not to be confused with microdata, which I'm hoping Peter will talk about in a bit more detail tomorrow, because I don't go into that in much detail, but flag that up as a related development. So let's have a look at some examples. So this is what I mean by very, very granular. So here, this is just the rel microformat, the rel license microformat. This basically says, if you embed this link, a link to a particular page, and you use this rel equals license, then that's your way of indicating how the content on the page that includes this link is actually licensed. So if you have an HTML page with that link in it, that says this document is licensed under a Creative Commons Attribution 2.0 license, which I'll talk more about later. So that's the smallest possible unit you can really use as a piece of structured data in an HTML document. And that's really useful. This is great stuff. Then there's slightly more elaborate microformats like Geo, which provides a somewhat standardized way to embed structured data about a location, a latitude and longitude. What you'll notice, if you look carefully, is that this says nothing about what the subject of what this latitude and longitude relates to. It says, it just says there is a latitude and longitude. There's a location with these coordinates. It doesn't really tell you more about that location. You might infer that this somehow relates to the topic of the page. So if you had a home page for a person with this on it, you might think, well, that's someone's house, maybe, or the place where they work. Or if it's a shop, then maybe it's the location of a shop. But the relationship between the thing that's at that location and the location itself is implicit. It takes a human being to come along and understand or make sense of what that relationship is. There are a number of other microformats at varying levels of standardization. HCard for kind of business card and personal information, HCalendar for calendar events, HProduct for products, HRecipe for recipes, that sort of thing. So this was a huge trend, a huge thing in the the mid-2000s, and it got a lot of traction. The drivers were really around is adding structured data so that other people could reuse it in some meaningful way. And a particular example of that was search engine optimization. Give the search engines better hints about your data, your content, and then they can do more useful stuff with it, and therefore drive more traffic to your content. But it came with a bunch of limitations. So there's really no underlying data model behind this. So to give an example, during my PhD, I was working on something related to online reviews, and I thought, well, microformat's great. This is structured data. As well as providing RDF data, I'll encode microformat data in my HTML documents. So I followed the little primer on the microformats website, and I implemented my hreview microformat markup. And then I wanted to test whether I'd implemented it correctly. Because you're embedding data within the HTML DOM, and it's sometimes quite hard to see whether what you intended to say is what you've actually said. So I contacted one of the people in the community to get some kind of feedback to understand whether I was actually embedding this correctly, and said, well, how do I validate this? And his answer was, well, if you process your HTML through the XSLT script that this guy's developed, and if what you get out is what you intended to put in, then you've done it right. My response was well, how do I know that the guy has implemented the XSLT correctly? And where is the underlying data model? Where is where's the formal semantics in this? And the answer was that there isn't any. If it's interpreted correctly by whatever's consuming it, then it's correct. And I just don't really think this is a scalable process. I don't think this is a kind of scalable, reliable way of publishing data on the web. And so that was the point at which I said, well, we need something more rigorous and more well-grounded. which is really disappointing, actually. I remember at the time I was really excited about microformats, and then I tried them, and I found that they didn't work, and I honestly can't explain how disappointing that was. So that was what really drove me fully into the semantic web stack. And just to recap briefly about to talk about the web as a file system. So examples, like I said before, CSV files and database dumps. And the drivers for this really were about the ease of distribution of that data. So there are a number of limitations of this from a web perspective. So if you're publishing large chunks of data on the web, then it makes sense to compress it. So there's widespread use of compression when publishing large volumes of data on the web, which is great. And I don't mean compression by the HTTP server. I mean compression by the person publishing the data who then uploads it to an HTTP server. So in many ways that's great. It saves bandwidth, makes it quicker for people to download. But it means that the contents of that compressed file is not readily accessible to applications that want to consume it without first uncompressing it. So this, from a web perspective, really limits the extent to which the contents of that data is visible. It limits the ability for people to reference items in that data from elsewhere on the web, because there's this intermediate decompression step. So in terms of database dumps, again, like proprietary implementations of SQL, you could imagine doing a MySQL export. You have the whole SQL definition of your database. You can imagine zipping that up or gzipping that and putting it on the web. Maybe that's great, but maybe in other cases there's proprietary database formats. And does this mean, to make sense of this, that actually user agents need to embed some kind of SQL interpreter? I don't know. Are they just going to treat that document as a bag of words, and then you'll get lots and lots of documents that refer to select or insert? That doesn't really seem like a particularly webby or particularly effective, reliable way of publishing data on the web. And in terms of the limitations of CSV, JSON, and XML, from a web perspective, I'll cover those later. So to summarize, the historical picture for publishing data on the web and using data that's published on the web is very fragmented, or has been very fragmented. But at the same time, we can see that the demand for data published and available on the web is undeniable. Like every day, every week, every month, then there's more and more data being published, and there's more and more applications that make use of that data. This is a trend which is indisputable. We saw the initial kind of indicators of this in Tim's original vision, and I think we're now seeing the reality of that. But in all of this, then the data itself has typically been a second-class citizen. It hasn't been there really as part of the web. It's been data on the web, but not really in the web. It hasn't been meshed in, connected in with the web as a whole into one kind of universal information space. So how do we move forward with this? So I think to do so, we need some kind of guiding principles. And I've defined this as these as guiding principles, that web data must be accessible and usable at scale. So if we want to understand what's going to be an effective mechanism for implementation or delivery of a global data space via the web, then these are two good principles to follow, three actually. Accessible, usable, and at scale. So what do we mean in practice? So accessible then means everyone should be able to access it via some common protocol. Okay, that's if we ignore access control issues, then HTTP, we all have access to that. That's great. But it also means it should be findable. So people should be able to discover data that's available on the web in the same way that you can discover an HTML document if it's linked from somewhere else which has already been discovered. We haven't really seen that very much to date with data on the web. So we actually need to be able to find, we need to ensure that the same mechanisms for finding data, same mechanisms are available for finding data as are for finding content. Yeah, that would be a great addition as well. Yeah, and I think what we'll see later on is that we have an open or an extendable platform for publishing that data. Yeah. So the data on the web also needs to be usable, and I mean that from two perspectives. It needs to be legally usable, i.e., people that want to consume this data need to have the legal rights and the clarity about their legal rights to use that, and they also need to be able to use it from a technical perspective. So there needs to be common standards here that govern the way that data is published. And to really emphasize the point here, this needs to be feasible at scale. So it's not enough to have some kind of ad hoc solutions or custom formats or solutions that say, if your application reads this correctly, then it's published correctly, because what about all the other applications that don't know about your internal thought process when publishing that data? This needs to be driven by common standards. So to go back to the overview of my talk, having given that kind of historical perspective, I want to look more at open data in some detail, because I think this is an increasingly important underpinning of publication of data on the web. And that particularly deals with the accessible and usable aspects of the guiding principles. And secondly, I want to talk about how we take data that's on the web, preferably openly licensed, and connect it together into some meaningful universal information or data space, and the technical mechanisms we'll use for actually doing that. So that deals with particularly the findability that I talked about before, deals with that findable aspect, and it also deals with some of the technical aspects as well. Are there any questions at this point? Okay, great. Was there a question in the audience? Hi. I think the incentives for data publishing are the same as for content publishing. To provide a way for, or the incentives for any aspect of best practice around content publishing, in order to be able to drive more visitors, greater audience to a particular piece of content. So I think from a search engine perspective, that's the big incentive, search engine optimization. But if we look more broadly, then there's also aspects around legal obligations around transparency, which are a big driving factor in the open data space as well. Beyond that, there's also incentives for organizations that want to have a more open innovation process. So for example, you might have a company that has a rich data set that it thinks it can use to create some or generate some business insight. It doesn't have the capability within its own organization to exploit that, or doesn't have the full range of ideas of how that might be used. And if that data is openly published, then through one of the different mechanisms that I'll talk about, then that's an opportunity for other people to come in and do something innovative with that data that the organization can then adopt and use that to cater to existing customers. Using existing business models. I'm not talking about reinventing business models. Does that answer the question? Okay. Sorry, I have one more. I'll take one or two more, and then I'll move on.
In case of usability of data, you were told legally some common standard has to be required. Some common standard is to be required in case of usability of a data.
Right.
So, as such, I don't find any uniform standards are maintained all over the world, because different nations have different legal requirement for using their data. So how do you propose an open standard?
So I think there's
some common standards.
Right. So I think the common standards exist at a technical level, at a technical syntactic level, in terms of the formats and more broadly the data models underlying those. In terms of the best practices for doing that, then those will also be, I think, defined by the community. But I think from a legal perspective, then there are lots of complications around in different jurisdictions about how the data is published. So I'll cover those in a moment. I think there's multiple different aspects to that. So one more, and then I'll move on.
Seems like the commercial interest and the privacy interest run counter to the open data principle, right? I mean, for example, open data would be more open if we had a way to, I don't know, say take Zillow, which publishes home information, I don't know, Glassdoor that publishes individual salary information, and you could actually do a public dialogue, right? But obviously that would run counter to commercial interest of those companies and probably the privacy interest of anybody that data is there, right?
Okay, so from the perspective of the Open Data Institute, then we're very, very clear that open data does not mean or does not include personal data unless the people that own that data and that data is about give their consent and choose to publish that. So I have data about myself, about where I work or my CV or my biography in some way, and that's my personal data. I can choose to publish that under an open license. But if someone else, a company, has data about me that they may claim to own but is my personal data, they should not be publishing that as open data without my consent. So it's really important to make a distinction between personal data and non-personal data in the open data space. And particularly with respect to the commercial interests, then we're already seeing plenty of cases where organizations are motivated to publish their data as open data because it drives traffic to their existing channels, or it enables them, like I said before, to create a more kind of open innovation process across with people outside of their organizational boundary. So I'll give some examples in a moment of that as well. Okay, let's move on. So part 3, open data. Being okay for time. So what do we mean by open data, to be specific? So this is the definition. There are a number of definitions out there. This is our preferred one because we think it's very, very clear about what we mean by open data. Open data is information that is available for anyone to use for any purpose at no cost. So to be really clear about this, for something to be open data, it must be explicitly licensed. It's not sufficient for me to take a data set that I own, post it on the web somewhere with no licensing statement and say, there you go, it's accessible to everyone, therefore it's open data. That's not open data. It has to have an explicit license that explicitly defines that this is open data and defines the terms under which people can use it. So a license might impose additional constraints on the users of that data. So it might require attribution of the source of the data, and it might require a share-alike component, which is kind of a viral component, saying that if you take this data set and you process it in some way and derive additional data, that derived data must be licensed under an open license as well. It must be licensed under the same license. So to emphasize the point once more, open data is not equal to the sum of open data is not equal to the sum of all the data on the web. Because there's a vast amount of data on the web which is accessible, but it's not openly licensed. So it only accounts for one aspect of our accessible and usable, or the accessible part of our accessible and usable principles. So why does this matter? Well, it matters because in a web page context, then for something to be accessible, basically, just the web page just has to be published, and that's usable as a finished product. A web page is basically a finished product. A human being can sit down there and read that and consume that, use that in some way. In most cases, data is not a finished product. It's a raw piece of data that's out there, and to really derive some value from that, then it needs to have further processing done on it. And if the terms under which that data can be processed are not made clear, then potential consumers have no sound basis for investing any time in processing that data. So the reference kind of example that we use a lot within the ODI is, would I remortgage my house or borrow a large amount of money from somewhere in order to invest in a startup business that was based on data which wasn't openly licensed, or where the licensing terms of that were unclear? And the answer is no. It would be completely crazy to say, right, I'll remortgage my house, and I'm going to build this great startup using this data set that I've just found somewhere. And it's not really clear who owns it or whether I'm allowed to use it in this way. It would be, from a business point of view, it would be completely insane. So it's really, really important that people that want to consume this data have clarity about the terms under which they can use it. Open content licenses that you can apply to images or blog posts or whatever. And they provide a legally sound way of defining the terms under which other people can use that. So there are a number of variants. There's one that requires just attribution. There's attribution and share alike. There's attribution non-commercial, saying you can't use it in commercial, You can't use it for commercial purposes, and what constitutes non-commercial is a little bit poorly defined. There's no derivatives, meaning you can't create derivative works off it, but you can use it for other purposes. That, it covers a range of different scenarios, and these are very well established, and they have their legal basis in copyright law. So copyright law internationally is very well established, it's well understood, and it's widely supported. It's supported in the form of copyright treaties between different countries, which seem to be better respected in some senses than extradition treaties between different countries, which is obviously topical at the moment. And from a legal perspective, it's predicated on the notion of creative works. So a book might be a creative work, a painting, a film script, a blog post, etc., etc. Anything that requires creative input is by default copyrighted. So that's a really important point as well. It's copyrighted by default. It's not something that has to be applied for. If you create that, you naturally have the copyright in that. A database licensing situation is a lot more complicated, and it's a lot more varied across jurisdictions. And I think this reflects the fact that sharing data on a worldwide scale is a new concept, it's a new thing, and the legal frameworks and the legal agreements haven't really caught up with the state of the art in the technology. It's also complicated by the fact that no one's really clear what we mean, or opinions differ about what we mean about a database. So when I say I'm going to license my database, what am I talking about? Am I talking about the structure of the database, like the schema and the column names, the table names? Am I talking about the contents, as in the values in the original in the rows or the cells of the tables of that database, or am I talking about the collection of all the individual data points or rows in all the tables? Well, I'm probably talking about all of those things. But from a licensing perspective, then these are each covered in. These are each treated in different ways. So the structure of the database, the schema, is covered by copyright. So if I'm creating a database schema, I've performed a creative work. I've used my creativity in structuring that database in a certain way, and therefore that's covered by copyright. If we're talking about the contents, like the individual table cells or rows, then the contents of those might be creative or they might be factual. So it might be that in one cell you have the entry from a blog post, and in another cell you have the timestamp under which that was created, at which point that blog post was created. So the former of those is a creative work. I've used my creativity to write a blog post. It may or may not be interesting, but I've used my creativity. And similarly, the computer has generated, or the server that's hosting my blog has generated the factual information about the timestamp at which I saved that. For the creative works, you see the previous slide, but for the factual works, there's no protection. There's no jurisdiction provides legal protection for individual facts. So this is a really important distinction. And part of the complication in database licensing comes from the fact that what we think of as one database may often combine a combination of those two different types of data, which would have different legal bases. So the collection as a whole, there is some legal protection for that in some jurisdictions. This is where it gets really complicated, because the EU has a very different legal framework around this than other places. And there's a great guide at this URL, which is where this particular material comes from. So I'll add the normal caveat that I'm not a lawyer. If you want some additional background reading on this, then start at this place and then follow the links from there. There's also a list of existing open licenses for data at this URL. And it's also worth saying that as well as licenses, which define the way that people can use the data, there are also what are called waivers, which are basically mechanisms you can use to waive your legal rights to data. So you can say, I apply this waiver, and I'm giving away all my legal rights, and by putting this into the public domain. So again, even if your intention is to publish some data on the web, and you want to give it away so everyone can use it, if you haven't explicitly said that that's what you want to do with it, then no one that's consuming it can be clear about how they can use that data. So if you want to give it away, that's brilliant. Put a public domain dedication on that, or a public domain waiver. So when we think about all these different licensing frameworks, then we say, well, how does that actually influence the open data ecosystem, or the data ecosystem as a whole? And what we've done here is an initial attempt at a simulation of what happens when you have an ecosystem that combines data that's licensed in different ways. So on the right here, the blobs with the red border are commercially licensed data sets, i.e. you're not allowed to use it for anything other than, we're not allowed to combine it with other things. Stuff on the left is data sets that are licensed with a viral share-alike license, and in the middle are more liberally licensed data sets that just have an attribution component. If you start this, the simulation runs by, you can choose the different input numbers or different proportions of data sets with each of these different licensing terms. So if you run a simulation where there's 5 or 10 commercially licensed data sets that can't easily be combined with other things because the licensing terms are incompatible, then you end up with an ecosystem of 5 data sets with no, you don't end up with an ecosystem, you just end up with 5 data sets or 10 data sets because they can't be easily interconnected. If you then add in a number of attribution-only data sets, then you start to create an ecosystem because those commercially licensed data sets can be combined more easily from a licensing perspective with the attribution-only data sets. If you then add in some more which are viral, then you see that you get an incredible density of interconnections between those data sets because everything that's derived from those is virally licensed. It's licensed on the equally open terms. So you get an incredible connection there. You never get the combination or the pollination between the virally licensed data sets and the commercially licensed data sets. So this is our way of helping to understand how commercially or restrictively licensed data sets restrict the growth of an ecosystem of interconnected data. You could argue as well that the viral licenses